Bright Tuty. Every student matters.
Hello students, my name is Sanjay Jain. We are discussing the chapter of surface areas and volumes. Till now, we have calculated surface areas of various combinations of solids as well as the volumes of various combination of solids, right? Now, we will study about conversion of solid of one shape into another. This also we have discussed briefly in our previous lectures that when we change the shape of a solid into another, the volume of the metal used or the volume of the substance that is used to form that solid remains constant. For example, if I have got a, let's say, a candle, okay, let us say this is the cylindrical shape of this candle that I have, right? If I burn this wax, okay, or if I melt this wax and convert it into a spherical shape, okay, using the same amount of wax that is used in this cylindrical shape, even in this case the volume of the wax will remain constant. Okay, this is the case for wax, otherwise it is true for every metal, for every substance that you change the shape into another solid, right? Let us say you have got a cylindrical shape, you change it into conical shape, the volume will remain constant. You change a spherical shape into a cylindrical shape, the volume will remain constant. So, we will use this fact to solve the questions in this exercise. Let us first of all do some examples to understand this concept better. Let us take this first example here. A cone of height 24 centimeter and radius of the base 6 centimeter is made up of modeling clay. Okay, we have got some clay and there is a cone made of it with height 24 centimeter and radius of the base as 6 centimeter. A child reshapes it in the form of a sphere. Find the radius of the sphere. We will use the fact that the volume of the clay used will remain constant irrespective of the shape we model it into. Okay, what I mean to say is I have got a cone of radius 6 centimeter and height 24 centimeter, right? And a child reshapes into a form of a sphere, okay? And we need to find radius of this sphere. Let us say the radius of this sphere is r. So, the volume of this conical shape and this spherical shape is same, right? Because the same amount of clay, entire amount of clay that was used in this conical shape is being used for making this spherical shape, right? So, volume of this cone is 1 by 3 pi radius squared into height, right? You remember 1 by 3 pi r square h, where r is the radius of the cone, h is the height of the cone, right? I have used 1 by 3 pi radius square, which is 6 square, into height, which is 24. It should be equal to volume of this sphere, right? What is the volume of this sphere? 4 by 3 pi radius cubed, and I have taken the radius as small r, so r cubed, right? Here this was just to explain the formula for the volume of this cone, right? I have not taken r as the radius of this cone, right? So, you can ignore this. Now, just the calculation part is left and I will get the radius. So, pi here can be cancelled, 3 can be cancelled on both sides. So, r cubed is equal to 6 square into 24 by 4. So, 4 6 are 24. So, I have got 6 cubed. So, r is equal to 6 centimeter. So, this is the radius of the sphere. Okay. The only concept that I have used here is that the volume will remain the same. Volume will remain the same irrespective of the shape that we are modeling it into. Okay. And other thing that is useful in this question is the formula. You should be thorough with the formula that the volume of cone is 1 by 3 pi radius squared into h. Volume of the sphere is 4 by 3 pi r cube. Right? I have used these facts to solve this question. This was a pretty simple question. Let's deal the next question here. Selvi's house has an overhead tank in the shape of a cylinder. This is filled by pumping water from a sump, and a sump is nothing but an underground tank, right, which is in the shape of a cuboid. So we have got two tanks basically. One is in the shape of a cuboid, right. This is the underground tank or sump, right, and we have got an overhead tank which is in the shape of a cylinder. This is overhead tank. Now let's read the question. The sump has dimensions these. The overhead tank has its radius 60 centimeter and height 95 centimeter. So the radius here is 60, height is 95 centimeter. Okay, and these dimensions are 1.57, 1.44 and 95 centimeter. This 1.57 and 1.44 is in meter. Okay, please take care of the dimensions here. Find the height of the water left in the sump after the overhead tank has been completely filled with water from the sump which had been full. The situation is that this tank, this underground tank or this sump is full of water, right? And we pump this water or we take out this water and fill this overhead tank with the water, right? Once this tank is full of water, some water will remain in this tank, right? We need to find height of the water left in the sump. Whatever water is left in this sump, we need to find that height, this height, right? This is the question. So basically we need to find the difference of volumes of this sump and overhead tank, because this was full, right? So the amount of water is shifted in this tank, right? So some water will remain in this. Now if I subtract the volume of this cylindrical tank from volume of this cuboidal tank, I will get the volume of water remaining in this sump. Okay. So what is the volume of water left in the sump after shifting the water, after filling the overhead tank? It will be equal to volume of cuboid minus volume of cylinder, or you can write volume of sump minus volume of overhead tank, right? So volume of cuboid is length into breadth into height. Now you need to take care that this dimension is in centimeter, these dimensions are in meters. So either you convert every dimension into centimeters or into meters. So I'll convert these into centimeters, let's say. So this is in meter, so I'll multiply it by 100. This is in meter, I'll multiply it by 100. Now this volume is in centimeter cubes minus volume of cylindrical tank pi radius squared, radius 60 squared into height, which is 95, and this volume is also in centimeter cubes, right? So this is the volume of water left in the sump. Okay, and what we need to find out is the height of the water left in the sump, right? So this volume is for the water left in the sump. What is the length of this sump? 1.57. What is the breadth? 1.44 in meters, right? What is the height of water left? It is what we need to find out, right? So, if I say volume of water left in the sump is equal to 1.57 into 1.44 into height of water left. So, this is the volume of water left in the sump, right. So, this now is in meters. So, I will multiply these by 100 and one more 100 for this. It is equal to this difference here, which is 1.57 into 1.44 into this is 95 into 100 into 100 minus pi 60 squared into 95, right. So, height of water left, or I will denote it by H, is equal to this into this will become 157, this into this will become 144 into 95 minus pi can be written as 3.14 into 60 into 95, and this has to be divided by this, which is again 157 into 144, right. Now, this can further be written as 157 into 144 into 95 minus this 3.14 into this 0 into this 0, right. I am not multiplying it by 0, but I am making use of these zeros. This is 60 into 60, I can write it 6 into 6 into 10 into 10, right. I hope this is clear to you. So, I can write it as 314, and 6 into 6 can be written as 36 into 95 divided by 157. Why I am doing this? Because 314 is double of 157. So, I can take 157 common from it, right, and 36 4s are 144, 36 into 2 is 72, 72 into 2 is 144. So, 36 can also be taken as common. From here I will have 4 into 95, and from here I will have 2 into 95, right, divided by 157 into 144. This is just the calculation part, but I am doing it for just to simplify it further, right. So, 36 into 4 is 144, 2 can be taken as common from it, right. So, 2 if I take common, here I will have 2 into 95 minus 95 by 4. So, this is 2, 2 into 95 minus 95 is 95 divided by 2, right. So, this is equal to 47.5, and the unit was centimeter, right. I have converted everything into centimeters, and this is the height of the water left in the sump, right. Now, there is another question in this: compare the capacity of the tank with that of the sump, right. So, we need to compare volumes of sump and overhead tank, right. So, capacity of tank divided by capacity of sump is equal to, what is capacity of the tank? It is pi 60 squared into 95, and what is the capacity of the sump? It is 1.57 into 1.44 into 95 into 100 into 100. So, 95 can be straight away cancelled. Pi is 3.14, which is double of 1.57. So I can write 2 here, right? So this is 2 into 3600 divided by, this can be written as 144 into 100. Okay, so these two zeros can be cancelled. 36 into 4 is 144, so 2 by 4 is 1 by 2. Hence I can say that capacity of the tank divided by capacity of the sump is 1 by 2. What does it mean? That the capacity of the sump is double of capacity of tank, right? We need to compare these capacities. So I can say capacity of the sump is double of the capacity of the tank, right? Okay. Let's move on to the next question. Now I have got a copper rod of diameter 1 centimeter and length 8 centimeter, and it is drawn into wire of length 18 meter of uniform thickness. There is a copper rod, okay. Let us say the diameter is, let us make the diagram once again. Let us say this is the copper rod where the diameter is 1 centimeter, so the radius here is 1 by 2 centimeter, okay, and it is drawn into wire of length 18 meter. This is a rough diagram because this length is 8 centimeter here, right, and I have to make 18 meter. So if I draw on the same scale, it will not it will not be in this board, right? It will go beyond this board, but just consider that it is 18 meter length or 1800 centimeter of length, right? We need to find this thickness here. So what do we need to find? Actually the diameter of this wire, right, which is thickness, right? So now I know from the conversion of solids from one shape to another that the volume of the copper used in this rod and used in this wire is same. So what is the volume here? This is cylindrical shape, so pi radius square, radius is 1 by 2 squared into height, which is 8. It should be equal to volume of this wire. So volume of this wire is pi radius square, radius I don't know, so I'll denote it by r, radius squared into height, which is also the length, right? Length of this wire is acting as the height of this cylindrical shape, so I am taking it 1800 here. Pi simply can be cancelled. 1 by 2 square, 2 square is 4, so 4 into 2 is 8, so I have got 2 here, right? And further if I cancel this by this, so this will be 900. So r square is equal to 1 by 900, or I can say r is equal to 1 by 30, and this is in centimeters. But I need to find the thickness. Thickness is diameter, right? So thickness of the wire or the diameter of the wire is twice of r, which is equal to 2 into 1 by 30, hence it is equal to 1 by 15 centimeter, right? So this is your answer for thickness of this wire. You can further convert it into millimeters and all, but this is your answer, right? Because it is not specified that you have to convert it into any other dimension, so I am leaving the answer in centimeters, right? Okay, let's look at this question now. A hemispherical tank full of water is emptied by a pipe at the rate of 3 to 4 by 7 liters per second. How much time will it take to empty half the tank if it is 3 meter in diameter? Okay, there is a hemispherical tank and it is emptied by a pipe at this rate, right? So this rate is 25 by 7 liters per second. Okay, and we need to empty half the tank. So whatever volume of this tank this hemispherical tank is there, we need to empty half of it, and it is 3 meter in diameter. So the diameter is 3 meter, so the radius will be 3 by 2 meter. So this is also 3 by 2 meter, right? So what is the volume of this hemispherical tank? 2 by 3 pi radius cubed, right? This is the volume of this hemispherical tank, and we need to empty half of it, so multiply it by half. So this is the volume that we need to empty, okay? And this volume is in meter cubed. So this is the volume that we need to empty, okay? Now the rate is given 25 by 7 liters per second. So 25 by 7 liters of water is emptied in 1 second. So 1 liter of water will be emptied in how much seconds? See, 25 by 7 is more than 1, right? 25 by 7 is 3 point something, right? So 3 point something liters of water is being emptied in 1 second. So 1 liter will be emptied in a smaller time, right? Lesser time. So it will be emptied in 7 by 25 seconds. But I need to empty this much water, and this is in meter cubes. So I need to convert it into liters first, and I know that 1 meter cubed is equal to 1000 liters, right? 1 meter cubes is equal to 1000 liters. So let me cancel this here, and this can be written as pi 3 by 2 cubes by 3 into 1000 liter will be emptied in, you have to multiply it by 7 by 25. So this is the time, pi by 3 into 3 cubes by 2 cubes into 1000 into 7 by 25, and this time is in seconds, okay? So let me calculate it here, pi by 3 into 3 cubes by 2 cube into 1000 into 7 by 25, right? So this can be written as 3 square, that is 9 here, right? And this is 2 cube, which is 8, right? So 1, 2, 5, and this will give you 5 here. So this is equal to pi into 9 into 5 into 7. So if I convert pi into 22 by 7, I can write it like this. 7 can be cancelled here, and 9 into 22, 18, 19 into 5, 198 into 5 seconds. So we can also convert it into minutes by dividing by 60. So this much minutes time is taken. So 5 into 12 is 60. So 12 ones are 12, 7, 78. So 12 6 are 72.5 minutes. So I have converted these seconds into 16.5 minutes. So it is the time 16.5 minutes that will be taken to empty half the tank, right? Okay.